Hey everybody, welcome back to part two of fixing the Z-axis ball screw and ball nut on our 1999 Haas VF2. I'm over here at the lathe. I'll bring you guys in. I was able to get this ball screw pretty damn accurate. I got it within 1/1000th of an inch overall. And I'll bring you in and kind of give you a quick rundown exactly what I had to do. And so let's get started, and hopefully we'll get this wrapped up today. It is Monday, but hopefully get it fired up and get it working again. So let's get to it. Okay, so we have it here in the lathe, and I had to do a couple things to get a very accurate measurement. I used an angle cube and used each jaw as a measuring point at 90 degrees. And then, bear with, so as I did that, I initially had taken, I take a gauge pin, okay, 1/4 inch gauge pin, whatever, and I would set this indicator over the surface of the ball screw, and I would take it, laying it flat against the ball screw, and just rotate it into the indicator stylus. And every 33, 0.3 degrees, meaning each jaw, I would get a measurement, and wrote those measurements down here. A, B, and C being A, the chuck, C is the quill, the steady, the quill here, B being the center, and 1, 2, 3 being, I labeled each jaw as to reference off of. So 1A, and I just recorded what the indicator read out at. So, and you can see here on A, 5 thou off there, but again, it's all the way at the front. I'm not too worried about that. Both of those are at, what the indicator stated was 3.5 thou. In the middle, you can see 4 thou, 3.5 thou, and 6.5 thou. And on the end here, we had 6 thou, 3/10, 6 thou, 6 thou, 3/10. So, kind of gave me a pretty good idea on exactly where it was at, and looked at it overall. And I had to take my steady rest. I wound up putting a 5/8 bolt in it, putting a piece of aluminum underneath it, and just kind of tightening the bolt and the nut down just to force down the piece of aluminum onto the ball screw, and just carefully pressing it, watching an indicator, and go through and push down. And like I said, I got it within overall 1/1000th of an inch. As I'm rotating it through, doing my same check, from 1, 2, and 3 of the jaw, and got it pretty good. Within 1 thou is pretty dang good. So I'm going to do a quick little polish on this just to get it all cleaned up. And I believe it's about 8 o'clock in the morning on Monday, so we're just waiting for UPS to get here. We'll get the ball bearings, and then so we'll go ahead and just pause this video, but it'll be nothing for you guys. Once we get those ball bearings, then we'll start to assemble the ball nut onto the ball screw. Verify that, and we'll bring it back over here, check run out on the ball nut. So I think, yeah, I mean, I think it's pretty dang good getting it close to where it's about a thou run out of the difference here. And again, same measurements out here. So it was kind of one of those things we had to check. I did check the run out here, and to verify it didn't move. So, but kind of reset it up to kind of give you guys a good shot of exactly what I had to do. So I'll get it broken down, get it out, get it polished, and then we'll get right into doing the assembling it. So, all right, everybody, we're back at it. Our ball bearings did come in, UPS, and I went ahead and cleaned up the lower bearing block and bearing. I didn't take it out, didn't do any of that. Everything is fine. It feels really smooth. Cleaned up all the hardware, got everything ready to go. My feeders. So the first step is carefully sliding on the ball nut, okay? And then we're gonna start feeding these balls in. And let's do it on time lapse because it's a huge pain in the ass. But with that, so when we get down, and I'll go into detail, when we get down to installing these, I'm actually going to use O-ring lubricant, and it's just like any petroleum jelly or anything like that. So we're actually going to count and feed the balls into each one of these recirculating tubes, and when we do that, then we're going to take a little bit of the gel and just kind of smash it into there. That keeps the balls from falling out, and then we can then install them in there while it's on the ball screw. I did polish it up. It is also very straight. So I want to get this wrapped up so we can get it in there. And so let me jump to a time lapse, and we'll get to watch me put this thing together and lose probably half those balls. All right, so we're over here assembling. I had to do this twice because I realized that the alignment of my transfer tubes were just a little bit off. So again, put this on as well. You got to thread this one on first, and then set the ball nut on the ball screw and put one of the recirculation tubes in. Okay, and then again, we're just dropping the balls in. When you first get them started, you don't want them to run too far down, so you'll hold the ball nut up against the bottom of the ball screw and drop them in, and they will fall down. Get them in enough to start allowing them to backfeed so you can see them right at the top. And then, because if you keep rotating, you'll just cycle those so many balls in. You don't want to do that because you want one right after the other. So I'll drop it right on top of the other ball and then rotate it till it's just below the flat spot where the flat spot of the recirculation tube sits on. You want it just below that, so the next ball falls right behind it. This way it's not too soon or not too late. And you're going to keep feeding these balls in until you start to see them come out on the other side. So this is a 2-channel ball nut system here. We're just feeding them in. And then once we get this side done, we'll remove the second stage of the ball nut, the second channel. And we will do it to that side. But first we're going to have to just reinstall that recirculation tube. Just get this going. A little tedious, a little pain in the ass, but once you get the hang of it, it actually does move along. You could probably do one ball nut in about 10 minutes, maybe less. Yeah, I did have to take these back out it just didn't feel right. A little too tight. It felt like one of the balls were kind of jamming up. And I think that has to do with the recirculation tube wasn't really aligned that well. I did a piss poor job of marking them when I took them out, and that went away. So now I just used a pen grinder, and I marked the location of each recirculating tube, so there shouldn't be an issue. And then I repolished with a fine micro burr on my pen, on my little air deburr, and just repolished the running surfaces where the ball nut meets the recirculation tube for a little bit smoother of a transition. And again, these are slightly bigger balls as well. So I did wind up just polishing and kind of opening up, not necessarily opening up, just cleaning the transition of the recirculation tube into the ball nut body to have a better transition when the balls start to circulate through the recirculation tube. So once I get this one done, I'll start on the second one, get that wrapped up, and start the video off from there. Okay, I can just see a ball here coming up on the other end. I'm going to keep going until it is just below that surface, I think. Looks like. Yeah, we should be good there. Kind of hard to see with adequate light, but. All right, so welcome back to part 2, and I'm going to put a bunch of clips in this video, try to shorten it up and give you the final result. A lot of kind of figuring out, feeling things out, and running into issues, some self-inflicted, some just new to what this entails to replace it. Originally I had ordered the ball bearings the first time for the Y-axis, and it turns out, and I ordered new. I ordered completely new ball bearings, same part number, same everything. It's just the tolerance difference from the time I ordered those to now. So I still had quite a few of the original ones left. They actually ran a little looser versus the new ones, and I was getting way too much binding, and then at the same time too, I think I left out a total of 20 ball bearings, so 10 in each channel, and that seemed to work pretty good. And so as I was making I filmed the process of reloading this ball bearing, this ball nut, kind of running into the issues. So you'll see some of the clips from that, the straightening of the ball screw, and the assembly, and kind of a how-to, or my impression of how-to, of loading each channel of the ball nut. So it is ready to go. And I think also too, as I was installing this, this was in the machine and I fired it up. I didn't bolt everything up. Luckily I had the mental capacity to say, okay, let's just make sure everything is okay. And of course it wasn't. So I had installed the lower bearing block, and I installed it all the way on, so it would bottom out on this end. And I'm not too certain if that was the right call. It just didn't seem like I was all the way engaged up here. So there was just a couple things I'm gonna go over. So I'm gonna install the lower bearing block, but I'm not gonna tighten it all the way. I'm gonna leave some slack so it can move, so that I'd ensure that I'm tightening the top, because this is more important. no load sits down on this, because if you look, yeah, you could probably tap this bearing right out, and that's down. So the bearing stops here from going up, but down. I guess they do that so there's no load, preload going into the ball screw. So it could just, all this does is keep the bottom of the ball screw aligned, doesn't any pressure down. The ball nut is what is holding most of the pressure, and again, the counterbalance is what does all that. But the ball nut is what actually kind of holds it up, if you will. And the top nut that goes onto the top part of the shaft here, top part of the ball screw, and then the coupling and then the motor. So all that's kind of held up here, but in reality, it's not much. They weren't that tight, so I really can't recall back on the y-axis. So, but it works. It actually felt great, just like this one. Felt smooth. Not as smooth as I'd like, but given the circumstances and the time, it's actually I think it should work pretty well without any issue. But you know what, I'll find out. But before, it was definitely binding. I mean, binding really bad. And I kind of figured it was the wiper seals on the end, but yeah. And I also kind of thought I didn't kind of label the recirculation tubes. That it really wasn't it, but again, I labeled them, and I also took my little air Dremel with a small, tiny deburr ball lollipop, and I just kind of helped soften the transition from the ball screw, the ball nut to the recirculation tubes. Like I said before, there's some burrs in there that can occur, and which could kind of jam up a ball bearing. So I did that, and I relabeled them, and ultimately I think it comes down to these balls are just a little too tight. And I know what some people say, it's wrong. Okay, well, this is what I have. I'm not spending a couple $1,000s on this machine right now, and I know this is going to work. Now, I did put the majority of the ball bearings in here from the first batch of ball bearings, which did run lower, about 0.002 smaller than of a millimeter, smaller than the ones I received Monday. Today's Tuesday. So it definitely made a difference, and also leaving some of the balls out. So, and I think it's going to work without an issue. So, again, sorry if this second video jumps around a little bit. I'm going to put clips in from Monday, from yesterday, and I'll jump off of here. And when I bring it in, I'll have it back together and hopefully working, but I'll bring it in on a power-up restore, and this will be installed without any of the weight covers or the top motor cover, and just to verify that everything's working the way we want it to. And again, I'm going to install this with the lower bearing block loose for now, so the ball screw will kind of float in there, and get it to the point where it's just touching the bottom of that bearing. We'll tighten it up here first, and then we'll get in here, and then we'll tighten up that lower ball screw lock nut on the bottom. And I think all it does is really just keep the bearing in. I mean, that's the only thing it could do. It keeps the bearing from falling at the bottom. That's it. And then the bearing obviously just keeps the ball screw stable. So we'll get into it, and when you guys get back here, a couple quick flash for you guys, but about an hour for me, and I'll get it fired up. Okay, so I got everything together, and everything is working phenomenal. The repeatability on the Z-axis is 1,000%. So the repeatability is there. On the stroke, I'm just under a half a thou. So as I go to go up or down with touching my tools off here, then I'll start to see the repeatability is there. But again, if I want to go up, so right now I'm at 0, dead on 0, and if I want to go up with the Z-axis in a 10 thou increment, it's like 2/10. It definitely is like 2/10. I'll bring you in. So right now, just over, and again, this is resolution, this is a half a thou. So then we'll go up 10 thou, or excuse me, down 10 thou. We're just off 0. Let me, sorry for the buzzing noise, that's my 4th axis. So we're down, we're right on the line there. Okay, so that's dead 0. And I did just calibrate that on my surface plate, my Mitsutoi height gauge. And then we'll go up 10 thou. And they were at about 2.5. So 2/10.5. I mean, that's pretty good. And again, the repeatability of it is spot on. So I can't argue with that. And yeah, this is the SPI height indicator. It's 1 inch. So since I have the 4th axis, the HRT 210, it's 6 inches off the surface of the table. So when I come in here, I'll bring it all the way down to 0. I'm on 0. And you can tell it's like a 1/10 difference right now because I just did it. But I'll do tool measure offset. And it brings it to the true position of Z. But that's 1 inch off the surface of the table. So then we just come in, we add 5 inches, and we hit enter. And it brings us to our Z center line that we use in the program for the 4th axis. So we'll go up here. And now I'm going to touch everything off, each tool. But we got everything set, everything where it's supposed to be. It works phenomenally. I did have to come in and install it with the bottom bearing block nut loose and then snug it up. Torqued down the top ball screw nut down a pretty decent amount. I'd probably say closer to like 20 foot-pounds. Let me get you spinning around here. So like I said before, hopefully the sound is better too. I got a little earbud in. But like I said before, the repeatability and the from commanding a move to the actual value I was getting was anywhere from 2 to 3 thousandths off. So definitely hands down much better than I anticipated, with the repeatability being 100% and the command down to 2/10 and a half a tenth. So again, I'm ecstatic. Hopefully I get that return on the parts I'm making. Again, I do have a big job to do where I'll be utilizing the fourth axis, and there's datums on there, so the parallel surfaces have to be spot on. And going back, I know it's a 1998. I can't expect too much out of it. But however, you know, we fixed the y-axis. I added a lot of, or improved a lot of things, added a lot of things to this machine, which I'll do a quick overview on this. This clip of this video is going to end off the z-axis rebuild on this project. Hopefully you get everything, you know, of value out of it. The clips I'm going to add are from yesterday, where I was kind of frustrated in looking to see why I wasn't getting the result, going back and forth with the ball bearings, finding out that a batch we purchased last year are just slightly undersized than the batch we purchased 4 days ago. So real quick, I'll go over this and show you guys some of the little things I've done. Again, to touch off, new monitor here, and then so on the Haas control, this is a LAN card device from Shop Floor Automations. It being a 1998, it only has RS-232 port, so it's a what's called a DB25 pin. And when communicating with it using a DNC, it was never efficient. So I purchased this. I believe this is about $550. It has an 8 gigabyte SD card in it, so now I can send files via the Ethernet to the SD card, which is actually mounted inside the console. And I took out the old floppy drive, and that's actually the bracket that holds that LAN card device on there. And it runs back with an Ethernet cable to the DB25 to Ethernet adapter. So that's in there. And now I have access. All of my machines actually utilize it, them being on the older side, including my newer Haas VF2, because I guess they purchased it. It has the ability, or you could put the wiring in for the Ethernet control for the Mocon. I guess they just opted out of it, maybe because they had older technology on their computer side, CAD-CAM side, and they just utilized that. So, but my VF3 being in 1999 also has the Shop Floor Automations LAN device. So they all do, and it's really, once you figure it out, it's really simple because how I have them labeled in there, and it's nice to get to upload files to them. I do everything in MDI when I want to send a file to it. You can do list program, but again, it's limited to 1.5, 1.4 bytes, so it's not really optimal. So the MDI version is like drip feeding it in, but it's all in MDI. An MDI that can take, I mean, I haven't seen the limit of MDI. Again, new rebuilt transmission, rebuilt spindle from GTI Spindle in New Hampshire. Then we have new encoder belt, new small encoder gear that's driven off the transmission. A couple new components for the plumbing for the transmission oil feed. And again, we put a Haas fourth axis on here and a custom air-driven tailstock. I'm not going to go into the back cover. I don't feel like shutting this off and getting into the back cover, but it has 4 brand new Gen 3 servo amplifiers. And if you know, this being an older machine, it has a low volt system. So the Gen 1 and Gen 2 servo amplifiers needed a 12 volt signal to turn the amplifier on. Well, Haas originally, if you don't have any Gen 1 or Gen 2s, I just have Gen 3s, they say that the low volt power supply will burn out. That's true. However, it's an isolated low volt power supply for just the servo amplifier. So once I eliminated my last, I had a Gen 2 in there. I wound up eliminating that, and I forgot what I did with that. I think my VF3 needed one, so I swapped it out. And so with that being said, I just completely eliminated the low volt power supply for the servo amplifiers. And they got their main power from the Haas vector drive. So it was just pretty much removing it. And so that was a pretty simple thing to do. So it has all brand new servo amplifiers in it, not too much done in the back, upgrade wise. But all in all, it's a fantastic machine. It's now fixed the Z-axis. It's a very repeatable, very reliable machine. The A-axis, the fourth axis here, does give me sometimes, I guess it gets too much encoder feedback, or it's just, you can hear it humming. But I've never had it fail during an operation of me cutting something. Sometimes if it sits too long in one spot, it will give me an A-axis failure. But besides that, it hasn't given me any problems, and you know, they're expensive to replace, and I can only get a used one just because the Sigma version of it. Here, we have the back of the machine. I always try to keep a log of the last time it was trammed in. I'm due for another one. You always want to check the machine. But I'll get you spun around here, and I'll show you one of the things I think is pretty nice. So here, standard pump, standard filter. I actually just built a chute. This one's kind of crude, but it works. And I wound up cutting the top lid to the coolant sump and sliding back the tray. And then I wound up screwing in the chute far past, I think I put some rubber gasket material back there. But it works phenomenal because I get a lot of chips in here, and to drag it out is a huge pain in the ass. So this works phenomenally. And I'll swing around. My Ethernet comes into here. Here's my DB25 to Ethernet connection. And I think that's pretty much it. Cleaned out the oil system when I got it. It's still a little dirty. I didn't go too crazy when I got this machine. It's been used ever since. I think at one point, real quick, I just want to touch on that. And I do have to put it back together, obviously. But on the back of the machine, on the tombstone, actually it was on this machine, never mind. But, and again, to touch it off, I use all Mari tooling. Made in the USA, great stuff. And I only use their tool holders. Unless it's something special, then I'll use, like, I need a Sandvik or, but all their drill bodies. There are a couple things that obviously Mari Tool does not offer, but I do that anyway. I did just go through and clean this up. I didn't do a video of it, but I dropped that down, cleaned it up. There's a lot of gunk in there. So I did clean that up there pretty good. The Haas 5-inch self-centering vise. It's okay. I think they could have done better on the center nut retention. We actually wound up having to drill pins in it once we got it centered. Huge pain, because it actually would move. Huge pain in the ass. I don't utilize this because the nozzle hits the vise for the programmable coolant. So I kind of made a quick little manifold with some, I think I got these off of Amazon, old nozzles. I actually wound up making new nozzles out of 7075 with the balls on them. Just because the nozzles, they threaded into the ball and I didn't want them falling out. So that's all done. I'm going to wipe down a little bit inside there. I'm not going to go too crazy. But yeah, overall, very happy with it. I don't think there's anything else. I replaced the belt, the main belt that's in here that's off the transmission to the spindle. That's been replaced. And again, you can see the video of me briefly rebuilding the transmission. But, you know, again, I lost some footage and it was kind of a time crunch as well. So there's that. So we'll close this video off. All right, I want to thank you guys so much for watching this video. Please, any comments, drop them down. If I missed something, call me out on it. If I'm wrong, I'm not an expert at doing this stuff. It's just kind of best guess at this point. Like, subscribe, share the video, and shout out to Mari Tool. They've been helping me out too on some jobs here, trying to get tooling I needed. So really appreciate their help. Frank over there, Mari Tool, great company. Again, I'm not sponsored by them, but a well-deserved company, and they deserve a plug any chance they can get. And again, nobody cares. Work harder. Thanks. This is the Everyday Machinist. I'll see you guys in the next one.